we shall continue with the examples which are based on continuity of a function. Now, the next example is you have to check the continuity of this following functions. F of x is equals to, in the last class we have done 2x plus 3, 2x minus 3. Now the next one is mod of x divided by x if x is not equal to 0. If x is not equal to 0 and it is equal to 0 if x is equals to 0 at the point x is equals to 0. At the point x is equals to 0. Now remember, x not equal to 0 means for the values less than 0 and for the values greater than 0 the function is going to be mod of x divided by x. So if I draw the real line here, so at which point we have to check? At the point x is equals to 0. So at x is equals to 0 the function f of x is defined to be 0. But for the values x not equal to 0 means f of x is mod of x divided by x, and here f of x is mod of x divided by x. Now here for the values less than 0 and for the values greater than 0, though the function is defined in the same manner, but still here I have to apply LHL and RHL because of the modulus function. So here so first at x is equals to 0, f of x is 0, so f of 0 will be equal to 0. This is result number 1. Now LHL will be equal to limit of f of x as x tends to 0 minus, which is equals to limit of mod of x divided by x as x tends to 0 minus. Now for the values less than 0, this modulus function is defined by minus x. So this will be limit of minus x by x as x tends to 0 minus, which is limit of minus 1 as x tends to 0 minus. So the value is minus 1. Now we shall see what is the RHL of this. So RHL will be equal to limit of f of x as x tends to 0 plus, which is equals to limit of mod of x by x as x tends to 0 plus, which is, so for the values greater than 0 mod of x is positive, so that is x by x as x tends to 0 plus, which is limit of 1 as x tends to 0 plus, which is equals to 1. Now you look here, LHL is not equal to RHL. LHL is not equal to RHL. So the function is not continuous. The function is not continuous at x is equals to 0. So this is how we are going to solve it. Now the next example, if we want to see, the next example is f of x is equals to, now first we shall solve the examples. F of x is equals to mod of x plus 3 if x is less than or equal to minus 3, and it is minus 2x if it is minus 2x if it lies between minus 3 and plus 3, and it is 6x plus 2 if x is greater than or equal to 3 at x is equals to minus 3. You need to check it. So first thing that we have to do is draw the real line. Here there are two values, one is minus 3, another one is plus 3. Values less than or equal to minus 3. Remember, values less than or equal to minus 3, the function is defined by, for less than it is defined by mod of x plus 3, and at x is equals to 3 it is a mod of x plus 3, and in between minus 3 and plus 3, so it is minus 2x, right? In between this, at x greater than or equal to 3, 6x plus 2, this is 6x plus 2. Now remember, at x is equals to minus 3 you are going to check it. At x is equals to minus 3, f of x is defined by mod of x plus 3, which is mod of minus 3 plus 3, which is 3 plus 3, which is equals to 6, because mod values you are going to consider it to be positive only. Now here for the values less than minus 3 and for the values greater than minus 3, the function is defined in two different manners. Remember, for the values less than minus 3 and for the values greater than minus 3. So here I have to apply LHL. So here LHL will be limit of f of x as extends to minus 3 minus. So it is limit of mod of x plus 3 as extends to 3 minus, minus 3 minus. But for this it is minus x. So it is mod of minus 3, right, minus x plus 3 as extends to 3 minus minus. So this will be minus of minus 3, minus of minus 3 plus 3, which is 6. Again, RHL will be equal to limit of f of x as extends to minus 3 plus, so that is limit of minus 2x as extends to minus 3 plus, which is limit of minus 2 of minus 3 plus h as h tends to 0, minus 2 into minus 3, that is 6. Here it is minus 3 minus 0, right? So that will be equal to 6. Here h tends to 0. So since all the three answers are the same, the function is continuous. The function is continuous at x is equals to minus 3. Now as an exercise, I will be giving check it for x is equals to 3 as for example, right? Now these are the examples, and from the exercise 5.1 you can have a look at this. Now the next concept that we are going to study is the algebra of continuous function. Now here, if there are two or more continuous function, then what about the addition of those, subtraction of those, right, and all the other algebraic terms that we are going to see. Now algebra, I will be giving you here algebra of continuous. We are going to solve some more examples, don't worry. Algebra of continuous functions. If f of x and g of x are any two continuous functions at x is equals to a, then the following rule holds good. Remember, first rule is that f of x plus g of x. Second, f of x minus g of x. Third, f of x into g of x. And fourth, f of x divided by g of x. Here, provided g of x is not equal to 0, are all continuous functions. They are all continuous functions at the point x is equals to a. Remember this. They are all continuous functions at the point x is equals to a. Right? Thank you.